Okay, in our final section of our video today, we're going to talk about the inverse tangent function. So remember, the purpose of today's class is to be introduced to the three inverse trig functions that we're concerned about: inverse sine, inverse cosine, and inverse tangent. And at the end of today, and after you have taken a look at some of these functions and practiced them and drawn them a few times, you want to be comfortable if somebody says to you when you're hanging out on the street, "Hey, what does the graph of the arc cosine function look like? What is the domain of that function? What is the range of that function?" And you want to know those important properties for all three functions, and you want to be able to draw pictures of all three functions with their important x and y labels on the graphs. Okay, so to talk about the inverse tangent function, or arctangent function is another name for this, we want to start, just like we did with sine and cosine, we want to start by drawing a picture of the tangent function. So the tangent function, we need to draw all of our important x values, and you might remember that on the tangent function we have vertical asymptotes at all of the pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, etc. Okay, so this is our tangent function, and the thing is that just like with the sine and cosine function, this tangent function does not pass the horizontal line test, so we need to restrict the domain for this function so that we can have an inverse. And the way that we restrict the tangent function is that we will restrict the tangent function to the portion of the graph between the vertical asymptotes of negative pi over 2 and positive pi over 2. So this is the same restriction as we have for the sine function. Different from cosine, but the same as sine. So let's focus on just that middle portion of the tangent function. So here's a picture. We've got our two vertical asymptotes at pi over 2 and at negative pi over 2. And we're just going to focus on this graph. Now, some important features about this are that our restricted domain is now negative pi over 2 to positive pi over 2. And notice that I have round parentheses now instead of square parentheses because we are only talking about the values between negative pi over 2 and positive pi over 2. Tangent is not defined at the asymptotes. So our restricted domain is the same as for the sine function, but not including the endpoints. And our range is negative infinity to positive infinity. Okay, so now we want to imagine what this graph is going to look like when we reflect across the diagonal line y equals x. Now, some things that I'm going to notice right away are that these vertical asymptotes that I have, if I have a vertical asymptote and I reflect that vertical asymptote across the diagonal line y equals x, that vertical line is going to become a horizontal line. So our inverse tangent function is going to have some horizontal asymptotes at pi over 2 and negative pi over 2. So the horizontal asymptotes are y equals pi over 2 and y equals negative pi over 2. Okay, so once we have these horizontal asymptotes drawn in, then I can draw this branch reflected across y equals x, and we get this picture of this nice purple function. So this is our graph of y equals inverse tangent of x, or y equals arctangent of x. Okay, so there's our picture, and now we want to talk about some important features of this graph. Okay, so I'm again redrawing this picture on the new page, and we have our horizontal asymptotes, and these guys, I'm going to label them on this picture. I've got a horizontal asymptote of y equals negative pi over 2, and another horizontal asymptote of y is equal to pi over 2. Okay, so now we're going to continue to draw this graph. Here it is. And lastly, we want to talk about the properties of the arctangent function. So again, and I can't emphasize this enough, it's important to know what the graphs of these three functions look like, and it's important to know what the domain is and the range. And so our domain, if I look at the picture, I can see that this graph actually heads off in both directions. Our graph heads off to the right and approaches this horizontal asymptote as x goes off to infinity, and our graph approaches the horizontal asymptote of y equals negative pi over 2 off to the left. So our domain is all real numbers, in other words, x values from negative infinity to positive infinity. And so that was our domain, and our range is y values starting at a y value of negative pi over 2, but not including negative pi over 2, and extending up to positive pi over 2, but not including positive pi over 2. So our range has open parentheses, and from negative pi over 2 to positive pi over 2. Our input into our function, our arctangent function, will be a ratio of sides, and that ratio of sides is going to be opposite over adjacent, represents the opposite side of the triangle over the adjacent side, or y over x. And the output is going to be an angle. And that angle theta is going to have to occur between negative pi over 2 and positive pi over 2. So when we look for our output value, when we start evaluating these inverse trig functions, which we're going to do in class on Wednesday, when we start evaluating these inverse trig functions, our output values for arctangent will be angles between negative pi over 2 and positive pi over 2, meaning angles in the fourth quadrant and the first quadrant. Okay, so this was our introduction to the three inverse trig functions. In our next class, we're going to talk about evaluating inverse trig functions and how to deal with expressions that involve inverse trig functions. Okay, thanks for listening.